And finally, we are in section 9.3. So let's get started with the final video and the final chapter of the final outcome, finally. Okay, so we're going to have to graph quadratics in two variables now. And in fact, we actually know everything we need to know already about all of this stuff because we did it with linear functions and we've graphed quadratic equalities before. So this is actually just kind of a review of all sorts of old stuff. Okay, so we want to graph the border or the boundary line for y less than -2 times x minus 3 all squared plus 1. So the border here, the boundary, is the equality y equals -2 times x minus 3 all squared plus 1. Well, this is in vertex form, so we know that the vertex is at 3, 1. That's about right there. We know this is going to open down. Maybe I'll plug a point in, like x equals 2, just to see what I get. Well, I'm down here. And x equals 4 is going to be over there. Okay, and so it looks something like this. Isn't that beautiful? So that's the boundary line. Okay, where is x less than, or y less than this? Well, you could test a point. Say test 0, 0. And if you test 0, 0, you get 0 less than -2 times 0 minus 3 squared plus 1. That's 0 less than, a lot, -18 plus 1, -17. Well, that fails the test. So that point 0, 0 is not in the region. That means the region is the part down here. Now, before I move on to the next question, I made a big mistake for which I will pay greatly when I hand this in on the test. The boundary should not be included because there's no equal sign. Uh-oh. Luckily, I have this eraser tool that I never really tend to use. And so I'll turn it into a dotted line and then refill it in with red, and just don't tell anyone that this is what happened, okay? It'll be our little secret. And there is the solution. Okay, I'll get rid of my test point since that's not in the solution area. And we're done. Next problem. Okay, we're going to graph this. Y is greater than x squared plus 5x plus 6. Okay, x squared is greater than y is greater than x squared plus 5x plus 6. Well, I could factor this. That's x plus 3 and x plus 2. That tells me I have two x-intercepts at x equals -2 and -3, with the vertex just tucked in between there. Okay, so you could try x equals 2.5 for the vertex, right? Halfway between the two x-intercepts is -2.5 for x. Well, we'll plug that in for y and see what we get here. 2.5 squared minus 5 times 2.5 plus 6. I typed it in and I get -0.25. Okay, so it's just barely down there. Anyway, what does the graph look like? Maybe I'll add a point. Let's see, the y-intercept is here at 6. Yeah, that's good enough. Oh, this time did I screw up by putting in a solid line? What do you think? Was the solid line warranted? Yeah, it was, because this time equals is included. Where should I graph? Well, we could test a point again. Let's test 0, 0. So test 0, 0. And we'll see, that would be 0 is greater than or equal to 0 plus 0 plus 6. Is that true? 0 is greater than 6? No, it failed. So 0, 0 is not in the region. That means the other side, this side up here, inside the parabola, is in the region. And so we shade it all really nicely. We do a great job of shading this program doesn't allow me to do an excellent job of shading. It's really up to you to really kind of impress me and wow me with your shading abilities. Okay? Don't do anything shady here. Anyway, there's the homework, and that's it, my friends. Thank you very much for listening to the whole course. Congratulations.